Okay, so here's a problem that was asked on the homework. It was out of 1.5, I believe it was 0.39, and the directions said to solve. And they gave you this problem right here, square root of x plus 2 plus the square root of 3x plus 10, and that is equal to 2. One of the questions on the homework was the person that sent this over email asked, which of these do I have to isolate? And it doesn't matter which radical you isolate, you just have to isolate one of them. And so we can take either one to the other side. I think I'll go ahead and subtract this one from both sides. Okay, so it's now going to look like the square root of x plus 2 equaling 2 minus the square root of 3x plus 10. The reason for isolating one of the radicals is so that when we go through and we square both sides, one of the radicals will go away. When you have two radicals in the problem, you're actually going to have to go through the process twice because you're still going to have a radical over here on this right-hand side after we square both sides. So let's square both sides. The reason for that is because when I square this is a quantity, so I'm going to have to FOIL it. Whereas here, square root of x plus 2 squared, that's just going to pop out as an x plus 2. Okay, but on this side, and I'll just write it out for you so you can see it, we actually have to FOIL this. So if I write it out in expanded form, that's what it's going to look like. So when I FOIL, it's going to be, the first is 2 times 2, so I'm going to get a 4. The outside 2 times the negative radical 3x plus 10, the 2 is going to stay on the outside. Same thing with the inside. I've got a negative and I've got a 2, so it's going to be a negative 2 radical 3x plus 10. And then here, when I multiply a radical times a radical, it's the same thing as having the radical squared. So this 3x plus 10 is actually going to pop out, and it's going to be positive. Okay. Okay. So I want to collect like terms now. I have x plus 2 equaling 4. These are like terms right here. Negative 2 and negative 2 is going to give me a negative 4 radical 3x plus 10. And then, oops, sorry, I should have collected like terms. This 4 with that 10 is going to give me 14. So I'll just make that a 14. And then we have a plus 3x. So here's what I was talking about. We went through and we squared this. We squared both sides to get rid of this radical, and that was fine. It did it on this side, but when we FOILed over here, we're still left with a radical in the problem. So we have to go through the process again. We now need to isolate this radical and then square both sides again. Okay, so this is going to look like taking the 14 and the 3x to the other side. Okay. All right, so this is going to become a negative 2x minus 12 equal to, on this side, negative 4 radical 3x plus 10. Now, you can divide both sides by negative 4 to completely isolate the radical, but because it's going to introduce a fraction over here, if I divide by negative 4, I'm gonna ignore doing that. I'm not going to do that. We can still square both sides, and we'll just have to square the negative 4 at the same time as squaring this. Okay, so at this point, I'm going to go ahead and square both sides again. This is a FOIL again. So if we write it out, it's negative 2x minus 12 times negative 2x minus 12 equal to, on this side, negative 4 you need to square, you get a positive 16, and then you square the square root of 3x plus 10, and the 3x plus 10 is going to pop out. Okay. All right, so let's go through and FOIL this. First is going to be 4x squared. The outside, positive 24x. The inside is a positive 24x. and the last is a positive 144. And that's equal to 16 times 3. It's going to give me 48x, and then plus 160. Okay. Okay, so what I'm going to do now is I have a quadratic, and in order to solve a quadratic, I want to set it to 0. So let's first of all just collect like terms on this left-hand side. I have 4x squared plus 48x plus 144 equals 48x plus 160. Okay. Okay. What I want to do now is set it to 0, so I'm going to take the 48 and the 160 to the other side. So let's subtract 48x and 160. You'll notice what's going to happen here is that my 48x, my x term is going to go away. It's going to add to be 0. And that's okay. So we're left with 4x squared here. This is going to be a minus 16. And then equal to 0. Okay, you can do this a couple of ways. You can do it as a difference of squares. You can do it by factoring difference of squares, or you can just solve it using a radical. So I think I'm going to just solve it using a radical. If I add the 16 to the other side, I have 4x squared equals 16, and divide by 4. Then I have x squared equals 4. And at this point, if I take the square root of both sides, I have x equals plus or minus 2. Okay, now I need to check these solutions because it's not a guarantee that they're going to work. So we've come up with x equaling plus or minus 2. We need to go back to our original problem, which is this, square root of x plus 2 plus square root of 3x plus 10. And that's supposed to equal 2. Okay, so first, let's check x equals positive 2. If I plug that in, I get the square root of 4, plugging 2 in here, so 2 plus 2 would give me the 4. And then if I plug it in here, 3 times 2 will be 6, plus 4, 3 times the 2 when I plug it in would be 6, plus 10 would give me 16. Okay, this one's not going to work because this is going to end up being 2 plus 4 equaling 2. That's 6 equals 2. 6 doesn't equal 2. So x equals 2 is not a solution. Okay, let's try x equals negative 2. So x equals negative 2. Plug it in here. I basically have the square root of 0 because negative 2 plus 2 would give me 0. And then plug negative 2 in here. 3 times negative 2 is negative 6 plus 10 is 4. So that's 3 times negative 2 plus 10. Negative 6 plus 10 gives me the 4. And so this solution will work. Square root of 4 is 2. Square root of 0 is 0. So I get 2 equals, I get 2 equals 2, and that's true. So x equals negative 2 would be the solution in this problem. And like I said, it doesn't matter which direction you do it. If you had solved and moved the square root of x plus 2 over first, you would still end up with the same solutions. Okay.